In problem number 29, we have 2x to the negative fifth y squared all cubed. We're going to apply that exponent of 3 to all three values being multiplied together in that set of parentheses. We're going to get 2 to the third, x to the negative 15th, y to the sixth. 2 to the third is 8. So we get to this point, we're at 8x to the negative 15th, y to the sixth, which is a good answer. However, we do have a negative exponent, so we can make it more simplified. So we're going to make that a fraction, and we're going to multiply by a version of 1. We're going to multiply by x to the 15th over x to the 15th. Now in the numerator, we have 8x to the 0th, y to the sixth, over x to the 15th. Recall that anything raised to the 0th power is 1. So we have 8 times 1, which is 8, y to the sixth, over x to the 15th. In problem number 30, the problem starts as x cubed y squared all to the fourth, and that's over x to the negative second, y to the negative fifth. I'm going to clean up the numerator first. So we're going to apply that exponent of 4 to both values being multiplied in the parentheses, and we're going to get x to the 12th, y to the 8th, over x to the negative second, y to the negative fifth. Now I'm going to clean up the negative exponents with x first. So I'm going to multiply by x squared over x squared. In the numerator, we now have x to the 14th, y to the 8th, over x to the 0th, y to the negative fifth. Now if we multiply by another version of 1, y to the fifth over y to the fifth, we'll get x to the 14th, y to the 13th, over x to the 0th, y to the 0th. Well, anything to the 0th is 1, so we really have x to the 14th, y to the 13th, over 1 times 1. We don't need to write that in the denominator, which gets us a final simplified expression here as x to the 14th, y to the 13th.